Okay. So as I said, the mass of a mole of an element's atoms is its molar mass. We get that from the periodic table. So hydrogen being 1.01, a mole of hydrogen, oops, don't need that extra line. A mole of hydrogen would be 1.01 grams. Okay. And when we're looking at molecular mass, this is the term that we use for molecules. The example that we did is carbon dioxide. Formula mass is the term that we use for ionic compounds. The example was table salt, which is NaCl. Okay. Let me know when I can move this down. We're good? Okay. Let's come down here. And then when we're talking about ionic compounds arrange their ions in unique crystal structures. And the simplest ratio of those ions in the crystal structure is called the formula unit. So this term, formula units, this is used with salts, which are ionic compounds. So like a mole of sodium chloride equals 6.02 times 10 to the 23rd formula units. It would be that many things in that substance. Now, you may abbreviate, and I'll talk about this later. You may abbreviate formula units. It's a widely accepted abbreviation, FU. Okay? All right, so just to reiterate, the molar mass of something would be the atomic masses from the periodic table to the hundredth place. It's atomic when we're referring to a single atom. It's molecular when it's a molecule. It's a formula mass when it's an ionic compound. And we use grams as the unit. Okay? You may also see AMU or you will see U, depending upon the situation. Okay? But it's all the same number. All right. Can I go on? Okay. So let's go ahead and practice this. Let's go to the next page. And then let's calculate the molar mass, molecular mass, formula mass, whatever it is, of these different substances. Number one wants us to calculate the molecular mass of nitrogen dioxide. They assume at this point you are able to write the chemical formula given the name. Okay, nitrogen dioxide is NO2. So then if I want to calculate the molecular mass, I'm going to take one nitrogen from your periodic table, which is 14.01, and I'm going to add that to two oxygens. Oxygen is 16. Okay, you're going to end up getting 46.01. And then for the molecular mass, we're going to go ahead and put grams, and we're done. Okay. For number two, if we're solving for the molar mass of sodium dichromate, you've got two sodiums. So 2 times 22.99 for sodium plus 2 times whatever chromium is. Chromium is 52. And then we have 7 oxygens at 16. So when I add all this together, I'm going to get 261.98. Molar mass is typically in units of grams per mole. And they write it as G/mol, implying that that's the mass in a mole of that substance. Bless you. Is this easy enough? Okay. All right, bless you again. Now, we can use the molar mass, because it has a fraction unit, to convert between grams and moles if needed. So that's what we're going to do, and then we're done with this section, and then I'll let you guys work on this homework. So let's take a look at the bottom of the page. Okay? So let's come down here, and we're going to convert between grams and moles using these fractions. So if I'm converting moles to grams, you're going to multiply by grams over moles. Grams to moles, you're going to multiply by moles over grams. So let's take a look at practice problem number 1 right here. What does 2.65 moles of table salt, which is NaCl, weigh? So that means we're solving for grams. Anytime they ask you for the mass or something and they don't give you a unit, it's grams. Okay, so we're going to take 2.65 moles of NaCl, and you need to cancel this unit, moles of NaCl, so we're going to write that unit on the diagonal. And then we're converting to grams, so we put it on top. The number 1 always goes where moles is. So will the number 1 go on the top or the bottom? Bottom. Yeah. And the number that goes here is the molar mass of NaCl. So that means we're going to take 22.99 plus 35.45. That comes from that new periodic table. Okay? This is going to be 58.44. And then you're going to multiply across. So 2.65 times 58.44, enter. And then you guys have got 3 sig figs in 2.65. The number 1 is infinite sig figs. The 58.44 is 4 sig figs. So I want 3 sig figs in my answer. So this comes out to be 155 grams of NaCl. Okay, you try number 2, and let's see what you come up with. Did you guys get 15 grams? Okay. Turn to the last page then. Okay, so let's go in the opposite direction and then we're done. So here we converted between moles and grams. On the last page, we're converting between grams, from grams to moles. So here, oh, and by the way, before I move on, in case you're given a multi-step problem, like you might be using this conversion down here in number 3. It's 1 ton is 1,000 kilograms. In case you're given a problem that asks you to convert to tons, this is what you would be using, okay? Right here, let's take a look at, let's do number 3 as an example, okay? Here it says smelling salts are used to revive an unconscious athlete. A capsule of smelling salts contains 500 milligrams of ammonium carbonate. How many moles of ammonium carbonate is this? Okay, so here you're going to notice that we are given milligrams instead of grams. You need to convert milligrams to grams first, and then you can convert grams to moles using the molar mass of ammonium carbonate. So this is going to be 500 milligrams. And then milligrams to grams is a one-step metric conversion. The number 1 goes where the prefix is, which is milli. Milli stands for 10 to the negative 3, so it would go up on top like this. Okay, and then we can convert grams into moles using the molar mass. All right, so let's calculate the molar mass. So we have got 2 nitrogens, because you have to distribute the 2 to everything inside the parentheses. So 2 times 14.01 for nitrogen, plus we have 8 hydrogens. So 8 times 1.01 for hydrogen, plus carbon is 12.01, and then we have 3 times 16 for oxygen. Okay, when you add all of that together, you're going to end up getting a molar mass of 96.11. And that will go here. And when we put this in our calculator, this is going to be 500.0 times second E negative 3 divided by 96.11. Enter. Remember, the number 1 is exact. It has infinite sig figs. The power of 10 is exact. I have 4 sig figs here. I have 4 sig figs here. 4 sig figs is the fewest, so that's how many I'll have in my answer. You should get 5.202 times 10 to the negative 3 moles of ammonium carbonate. So it looks like that. Okay, that's the end of 3.2. So 3.1 and 3.2 homework are open, okay? So I want you to do those, and then we will do 3.3 and 3.4 today as well, okay? We're not going to do a lab today.